Okay. So just two notes. I put these RMD files up to that address if you can read it. So it's GitHub and then r-hub and package building workshop. Just in case you want to. You know what? I'll make it all white and then it will. Just more readable. And there are some extra resources, obviously, on building packages. The two I would suggest is the first one is a book, which is also available for free online to read, and the second one is the proper reference for building R packages, which is a manual. It's called Writing R Extensions. So that has everything you need to do. You need to know, sorry, everything you need to know, and it's regularly updated for the newest versions. Okay, so we've seen that checking packages is useful. It's so useful actually that if you want to, if you want to publish them, release them to Grain or Bioconductor, then people running these services, they also do check your packages, so that they are at least syntactically, correct, and they do perform a lot of extra checks even, which is a good thing. The difficult thing is that not most of our code is portable and works, on most R versions and most operating systems, but not necessarily all of it. If you have compiled code, then you have potentially a lot more problems with portability, across different operating systems and so on. And if you want to publish your package, you have to make sure that it works on at least a set of common operating systems and recent R versions. And this is not always very easy to do. And even if you don't want to publish it, it might happen that you have a coworker that is using a different version of R, or a coworker using a different operating system. So it makes sense to create an R package to write code that is portable and works on both of them. But to check them, which means running these syntax checks and also running the tests that you have in your package across all these platforms, it's a hard thing to do. So that's what R-Hub does for you, basically. That's what it is currently. It's running RCMD check as a service. I will skip this. This is from a different talk, but I just thought I will show you a little bit of overview before I show you how to actually use it. So it will run these checks for you as a service. So you can submit your packages from a web interface if that's the way you want to work, to use it, or you can use it from R. So there is a client from R, which is an R package. I will have the links in the end to this. And from this R package, you can just start a check the same way as we were using DevTools check. That this check will be running remotely on an R-Hub server somewhere, and you can specify, what kind of platform you want and what kind of R version you want, and some flags and so on, which makes it a lot easier, obviously. Sometimes it's still not a joyride, because if you don't have problems on these other platforms, then it's good. Your package is fine on Windows and Mac OS and Linux and whatever, all different R versions. But if you do have problems on these other platforms, that can be still difficult, right? So because then you would need to have better access to these platforms to be able to see what these problems are and how to work around them, how to fix them. And just the submission of the check and the summary of how your check went is not necessarily enough. Anyway, so this is a difficult problem, and we are trying to see what we can do about it. But what we have currently is we have our command check as a service. It's a multi-platform service, so you can run your checks on Linux, Windows, Mac OS, and it can build you binary packages, which is sometimes pretty nice, especially if you have compiled code. If you don't have compiled code, it's not such a big deal. But if you have compiled code, then, building, so not just building, actually, this is also does the installing for you, because you learned, right, that the compilation happens actually at install time. So it installs the package for you, and then, creates a zip file of that installed package, and then people can install it, much easier. They don't need to compile it anymore on their system. So it also builds you, these binary packages. If you are interested in the actual architecture on how it works, exactly, it has a lot of pieces. You would interact with this front-end web app either through a web browser. Just go to the web page that I will have the link to at the end, sorry. Or the command line client interacts with the same web app. And then once you submitted your package, either way, that goes into a queue, and then there's a backend process that picks it up from the queue, which is pretty nice, because to have this separated from the actual, builds and schedulers, because sometimes we don't have, say, the builder available, because it's just we are upgrading the Windows or something on it, or whatever reasons, so there is nothing available, for your build immediately, but it will be still in the queue, so as soon as, something that is able to build your packages becomes available, it will start, building. We have an internal scheduler to do all the builds, which is Jenkins CI. If you're familiar with that, that's a CI software, itself. It's a general purpose thing. So basically, we are just adding a layer on top of that, and that's because we don't want to deal with, all the scheduling difficulties, which is, it can be a huge pain, to schedule all these builds across multiple build servers, across multiple operating systems. So Jenkins is written in Java, it's portable, it runs on most OSs, even on Solaris, hopefully. And, it can do all these jobs for us. We kind of use it in a transient mode. It means that, when you submit a package, then we create a Jenkins job dynamically. Because Jenkins is not very good if it has a lot of jobs. So you don't want to, have, jobs for, say, all CRAN packages and things like that. So, but your job is transient in Jenkins at least. So you have your submission, we create a job for that, and then, then it starts building at some point. And then when the build is done, we put all the results in the database. That's this project DB. We put everything there, and then we delete the job. So there is nothing in Jenkins. It's a stupid scheduler for us. Not stupid. It's just we are using it in a stupid way. It's not stupid itself. Okay, and then depending on what operating system you want, your job goes out of Jenkins, so Jenkins takes care of the rest, basically. It schedules your job either on a Linux builder or a Windows builder or a Mac OS builder. So things with a service like this can get tricky when it comes to isolation and security, because this is arbitrary code, right? So like people submit, it's R code, but it's not necessarily just R code, because you can submit C code as well, and then so on. Even just R code, you can run basically whatever you want on these machines, right? So we try to, mitigate, these risks, basically. So what we do is that all the builders that we have are basically throwaway machines. So they are instances in the cloud, and we can replace them, regularly. There's nothing important stored on them. It's just a vanilla Linux box for Linux. It's not so vanilla Windows or Mac OS, VM virtual machine for the other OSs, but we can just throw them away. So every mishap that might have happened on the machine is basically just transient. And on Linux, we also try to do something more, by using containers for each build. So for every build, we spin up a container of the type that you need for your build, and then the build happens in that container, and then when your build is done, we just remove the container. This is a little bit harder to do on Windows or Mac OS because there are no containers. So to do this properly, you would need to spin up a new virtual machine basically for every build, but that is slow. So there are some CI, continuous integration services, that actually work around this, but those are much bigger than us, and basically what they do is they are just running a lot of spares, or not a lot, but some spares. In case a build comes in, they're just running a couple of spare machines, spare VMs, and they can schedule them quickly. But we're not doing that because we are much smaller compared to them, so we don't want to run a lot of spare things. So what we're doing is we create a restricted user on Windows or on Mac OS that will run the check. So we create a user, the user will run the check, and as soon as the check is done, it has a time limit. So the user cannot run it forever. But as soon as it's done, we kill all the processes of the user, and then we remove the user, and we remove all the files that the user created. It's not a perfect solution, but that's what we have, and we'll see how well it will work. And so the Mac OS builders and the Windows builders are also kind of throwaway. So we have snapshots, and we just restore them, weekly from snapshots. So again, that gives some hope that we can keep them clean. Anyway, so this is how it looks. All the green things are implemented, and some of the black things are. So the GitHub part is mostly implemented. It needs a little bit of testing and a couple of new features, a couple of additional features, but otherwise it's done. So that would mean that you would basically be able to use it as a CI from GitHub. If you don't know what a CI is, it's a service that runs tests, or in this case, package checks, every time you have a new version of your code. So every time you push your new version of the code to GitHub, the CI has a hook on your repository and just picks it up from the repository, your code, and and it starts checking it and building it, and then usually it sends you an email if it's wrong, or it can be a more enterprise setup, that if you can even have like automatic deployment from a CI and so on. But we're not doing that with rHub. This is just checking. It's just a simple CI. So you will just get an email if something is wrong. Okay. Yeah. So I should probably do a demo to see how it works. So we have our praise package. But maybe I would do something else, something bigger. Praise package is great because it's small, but it might be more meaningful to do a bigger package as a demo. So I will use the rHub package, which is currently on GitHub. So you can install it from here. That's the API client. I have it installed already on my machine, so I can just use it. It's a small package. It doesn't have a lot of functions. Is this readable still? So if you list, all the functions in the package, these are all the exported functions. So you can see most of them, they start with check and check something. So there is a generic check function, which is just check, and then there are some specific ones, which is check on something or with something, which are just basically shortcuts to the generic check function. And then there are a couple of other functions, which I will show you in a second. So when you start using it, you download it, you install it, and then first thing you need to do is you need to validate your email, because we need to send out the results of the check to an email address, and we don't want, people specifying, even just by chance, other people's email addresses. We don't want to, send notifications to other people. So we need to validate that the email address is the submitter, is really, theirs. So there's this validate email function, which if you have emails validated already, it will just show you that you have some emails already validated, so you can revalidate them if you want, or you can add a new address. So if you start using this, you will have an empty list, so you will just have a new one. So I would just say that I would just make up like a fake one that I still own. This is fake too. And then, so now, this sends a request to our hub, and then our hub will send an email. It's the usual email validation thing, right? So our hub will send an email to this email address to check if it's really you or not, and hopefully I will get it soon. It goes to a different folder, and you get a token, which you just put into the rhub R package, and then your email is added, and now this is a validated address, so I can submit packages to rhub with this email address included. So when you submit packages for checks, by default it uses the email address of the maintainer, but you can override that if you want. Okay, so we have a validated email. So we can run checks, and we run them the same way, as we have been running the DevTools checks. But this is a different package, so we just say, check. If we just do that, then it will build the package from the current directory, okay, and it was submitted to our hub. But because I didn't specify any platform, it's giving me a list of platforms now that are supported, so I get to choose, one of them. So again, this is mostly useful if you need to check on a platform that you don't have. And in practice, that usually means that you have Windows, but you want to check on Linux or Mac OS or some other way around. Or you want to check on the development version of R, which all the CRAN and bioconductor people, maintainers are doing, but you don't necessarily want to update, R on your machine, or have multiple machines installed. That can be difficult sometimes depending on the OS. But here you can just choose, a version that has a development version installed. So I don't know. Tell me, what should I choose? Let's run it on. I don't know. Let's run it on Mac OS. That's good. That's fast. Say I'll choose 9. This one. And then. It's basically, this depends on the load, obviously, but if there's a builder available, that it just starts building automatically, immediately. And it looks like we have a builder available, so it starts, building immediately. So this output is a little bit restricted. If you want a more verbose output, then you need to go to this URL that is written here. So it's just saying, installing package dependencies. If you want to see, what those dependencies are and which one is actually installing right now, you just need to go to this URL. That's an updated, dynamically updated web page, and you can see it. You can see it there. Okay, here we are. Our RCMD check is running, so it started running. The output is really similar to the R command check. It looks a little bit nicer, with highlighted failures and successes and so on. So here are some failures, you see. So that function is unknown. This one is not documented. There's a test case failing, and so on. This is a package in development, so it has some failures. And then once this is done, it will also send you an email, about it. So the email will be optional in the future because, if you have it as a GitHub CI, you don't want an email about every, new version of the code checked. If it checks okay, you want emails about failures usually, but But right now, because we are doing these manual submissions, basically, it's you get an email, you know, every time. So if I come back here, it's not there yet, but it should be coming soon. Anyway, I will show you the email later. It was just an email about the failures, really. Okay, and that's pretty much it, you know. So you can run all these checks. There are a bunch of things to list, you know, your previous checks if you want to do that. So it keeps a database of those, and then you can query them. This is the last 20, I think. And oh yeah, I'll show this one. So this one is handy. So if you want to submit a package, then we have a function that is kind of appropriate for that, which is called check for CRAN, which checks on 3 or 4 platforms at the same time. So when you specify the platform, you know, the platform can be a list of platforms. Actually, it's not a single platform, and then, you know, it starts all checks at the same time. And right in the console, it's only showing the first one right now. I don't know what platform the first one is. I think it's Linux, probably, but it's running the others as well. And then you will get email about those too, and you can go to the URLs and see the details. So why don't we just do that? So we just go here to this one. And this one is a lot more verbose, as you can see. So it has some, is this readable? Not really. Yeah, so it's downloading the file, installing everything on the system that you need, you know, for this package. And then installing, yeah, this is a lengthy log. Yeah, querying your package dependencies, installing your package dependencies. Oh, and it's not done yet, it's downloading something currently. So this is where it is currently. I just got a message that I'm over my data limit on my phone, so I'm not sure how long this will go on working, but we'll see. Yeah, so I think this is Linux. This takes a little bit longer because it's just installing the packages takes a little bit longer. But from the first one, we are getting the first results, which are very similar to the previous ones, obviously. Okay. So this output is independent of the actual check process, you know, so you don't have to wait for it actually. So, you know, as soon as you submitted it and your build started, you can just, you know, interrupt it with Control-C or whatever your interrupt character is, and then it still, you know, keeps running in the back, and you still get the emails and everything. You don't have to sit here and, you know, and wait. Okay. It's a pity that you cannot really try it, you know. I mean, you can try it. I don't know what the status of the network is currently, but you can definitely try it, you know, at home or, you know, with a working internet connection. Okay, I will maybe show you a couple more things about some features that we have that you don't have with actually that's not true. You have them with the DevTools check, I think, but you don't have them with the normal rcommand check and the regular tools. So one of them is that when you specify your package dependencies, like this is an example, you know, description file. And this is something that DevTools supported first, you know, this feature that the remotes, you know, entry there at the bottom. So that's an entry to specify packages that are not coming from standard repositories, but they are somewhere else. So this is useful, you know, if you want to use, if you want to depend on or use, you know, development versions of other packages or packages that just haven't been published at all. You know, then you can use this entry, and it has some given syntax to specify where these packages are coming from. So in this case, this says that if you just say, you know, username / repository, that's by default a GitHub repository. So this is all documented in DevTools. There's a vignette in DevTools where the format of these are documented. But you can have them, you can get them, you know, from not just from GitHub repositories, but from various other places, URLs, or, you know, just plain Git repositories, other services like Bitbucket repositories. It works pretty well. So our hub supports this. So when we install, you know, your dependencies, we look in the description file and see if you have this field, and if you have that, then we install those first, and then it will work. It comes back as an error because that's a non-standard field, which is by design actually, because, you know, this thing will not work on CRAN, right? Because they can't install your dependency. So that's why it's by design like that. So if you pass it, it will be an error. Yeah. Okay. So the other nice thing is that you don't only have package dependencies, but you can have system dependencies. And the system dependencies are just, you know, additional other software that you need on the machine. Otherwise, your package doesn't work. And there is a field in the description file that you can add to specify these. It's called system requirements. It's like the bottom one here. But this is a free-form field. So this is basically just information to the user. It's not used by the R package management tools at all. So we make use of this field and try to parse this field and see, you know, just to parse out what the package actually needs to have installed on the machine to run, you know, successfully. And sometimes this is easy, sometimes it's harder, and it's a little bit manual, you know, the way it works. But, you know, without having like a formalized solution, there's not as much as you can do with that. So this one is pretty easy. It just says, you know, it needs libcurl, and it's even nice to you. It tells you that, you know, on like on one kind of Linux, it needs this package, and on the other kind of Linux, it needs that package. And this particular one doesn't actually need anything on Windows or Mac OS. So we have a database of these, you know, of these system dependencies. Like this is the entry of libcurl, and it's pretty simple actually, because on Mac OS, so that's this OSX row, you don't need anything, and on Debian Linux-based, you know, Linux platforms, you need this package, and on the other RPM-based, you know, Linux distributions, you need the other package, and we have a database of these. And if your package, you know, needs something else that is not in the database, all the database is on GitHub, so you can just, you know, tell us. You can even tell us what exactly your package needs on different, you know, different platforms, so you can just add it to the database, and then it works. Everything works automatically. So these are pre-installed. Okay. All right. So I don't know if you have questions about the RHub part. No. Okay. So these are the email notifications. You see, I had some errors and warnings and notes. And you have in the email notification, you have some links, and also on the web page, you know, to the full log or to the artifacts, you know, that are the build packages. So in this case, this was a Mac OS platform, and this is a Mac OS binary package that you can directly, you know, install on Mac OS. Even though the checks failed, you know, he was still able to build the package. So that doesn't mean that everything will work. Probably not, because a lot of these test cases failed, but it's still possible to install it. Yeah. Yeah. Yes, so dependency versions like R package for R packages. Yes, so that is a tricky thing. And it's mostly a tricky thing because the R package manager and the whole R package system doesn't really handle them well. And there's a reason for that. The reason for that is that there are cases when these dependencies are impossible to resolve because they can be conflicting and you can only load a single package once. So, if you have a package that says that it needs, version 1.0 and you have another package that says that it needs version 1.1 and you want to use both of these packages, that's basically impossible to do in R. Okay, with the package system because you can't load both of them. So what you can do is that, and what people usually do, they usually specify a lower limit for the version numbers, and that's usually okay. So you can do that in your description file, and I think one of the examples I showed you probably had that. I'm not sure if I can find it now, but you can specify, lower limits so that you can specify that you need at least this version, for your package. With RHub and DevTools in general, it's a little bit better because the remotes mechanism allows you to specify the exact version. Okay, but then it's your responsibility that no other packages that you are using are requiring a conflicting version of that. Yeah, so to do that, so it's not possible directly. So to do that, you would need to modify your submission basically and submit 2 times or multiple times. Yeah, but it's not really hard. So if you want to automate this, so I don't know what your motivation is, but if you want to automate it, it's not hard to automate it because it has an API, so you don't actually even have to call it from R. So you can call it from whatever. It's a JSON API. You can call it, from your tool if you want to do that. Okay. So let's see. Okay, so shall we go back to the package building stuff? Because I showed you basically what I wanted about RHub. So yeah, unless you have questions, we can look at writing unit tests a little bit, and then that would be the tutorial basically. So I showed you, I guess, most of these things that the RHub package does for you. Okay, so to write unit tests, there are a couple of ways to do that for our packages. And currently, I think by far the most popular is using a package called testdat. And DevTools actually integrates with testdat as well. And it will give you some helper functions to create your testing infrastructure and to run your tests. So that's what we will be doing now. I'll go back to the praise. Package that we've been writing. Oh no, this is the wrong praise actually. So the good thing is that with this DevTools and testdat integration is that it's very easy to add the testing infrastructure to your package. All you need to do is you call the DevTools use testdat function. And that says that it creates this directory, and then in the directory it creates this file. So all the unit tests of the package, they live in the tests directory. So why don't I just show you how the what the structure of the package is currently. I'm not sure if I can make this bigger. No, I can't, apparently. Anyway, so you can see that, we talked about most of these files and directories, and what is new is the test directory, which has a single file called test.r, which ideally you never have to touch, and then there is a directory called test.dat. So, and within that, this is the place where your unit test files go. Okay. So how do they look like? Let's take a look. So within praise, within tests, there is a test.dat directory, and then we can write our tests here. Okay, it is good to break up, your test cases to separate files, maybe along the same lines as you break up your code. So if you have, if you code, if your package are doing, various loosely related things, or just have, different functions basically, then you can test each function in a different test file if you want, and that's good practice. So all the test files, their names start with test. And then if you like, you can have a dash, but it's not necessary. So we can have a dash here, and I would just say, we have a single function, right? So I would just say test praise.r. This will be our test file. Okay, and there are three kinds of functions that test.dat is giving you to do, the testing. The first function is called context, and it's the simplest possible. It just declares the kinds of tests that you have in this file. Okay, so again, this is a very simple package, right? So we don't have a lot of different contexts. So I would just write that this file is testing, the praise function. Okay, so the second kind of construct that you get from test.dat is a function that is called test.dat, but with an underscore. So it's really easy to remember it apart from the underscore. And it has two arguments. One is a label that is completely up to you. It should be something meaningful so that whenever this test case fails, you will be, able to identify which one failed. So let's see, I would just say I want to test the praise function without template. It should do something meaningful without the template, right? So let's just test that. And you put all the test code into this second argument, which is an R expression. So usually it's between brackets. Okay, so what would be a meaningful test for the praise function without templates? Well, we just run it, and it should return a string, right? It should return a character vector of length 1, I guess, if the input was length 1. Well, there was no input, sorry, exactly. So there's no parameter. So let's just do that. So we run the praise function here. And then we use the third kind of construct that test.dat gives us, which is actually a family of functions. So these are the expectation functions, and they all start with expect underscore. And then you can expect a bunch of different things depending on what exactly you are testing. So the simplest of this is expect equal, which means that if I call praise, I expect this answer. But this is not exactly appropriate for us right now, right? Because this is a randomized function. So either we fix the random seed or something, or otherwise we cannot really use expect equal. But there are a bunch of other expectations, and anyway, what we wanted to test was that it returns a character vector of length 1. So we just say expect true, which is a very simple expectation. It just checks that the code that is in the argument, that what the code returns is a true value. So I just say here, so I expect that, when praise returns, it will return a character vector. Okay, that's a really simple, test, right? Okay, I can also say that I want a length 1 character vector, right? Okay, so maybe so much about praise without a template. So what's next? We should maybe test it, with a template, so that we have all variations. So this is a bit tricky again because this function is randomized, right? It's not so obvious to test, randomized functions. You could check, you could set the random seed. Maybe that would be a way around. Okay, so how should we do this? Well, I guess what we can do is that we can just call praise with the template and then see if it returns basically the same template with the substitution performed, right? Okay, so this is another expectation. It's called expect match. So that's string matching. It's regular expression matching. So it just means that, whenever I call this function with this template, I expect that the result will match, this expression, where the caret just means that it's the beginning of the string. So the beginning of the string should be I am. Okay, that's not too bad. Okay. So what else shall we test? So one thing that is worth thinking about when you think about, what exactly and how exactly you want to write your tests is that whether you should try testing the extreme values or values that are unexpected by your function. So what is it doing? What is it that it should be doing? If it receives something that was unexpected, not by design. Okay, so our praise function is actually not very good with that, right? Because it never really checks that our template that we passed on was really a string, or what was it, length, or was it any or not, and so on. So who knows what happens currently? We don't know, right? So this just suggests that it might be a good idea to add some check, to the function that is really a string and that is really length 1. And then if this doesn't happen, then it's your decision what the function should do. But a sensible thing to do is to throw an error. So let's just do that. Okay, so this looks good, hopefully. We can try it. Just load the new version with load all, and then, I would just try, calling it, say, with an empty list. Yeah, we get the error message, just what we expected, right? So that's the check that we added. So we can now test that praise indeed returns an error when it gets, an argument that is not what it is. Okay, so this is another expectation. It's called expect error, and it's very simple, right? It just means that, whenever I run this code, I expect an error. So we are just writing these tests, but it's probably time to run the tests now. So DevTools helps you with that. So what you can do is you can do DevTools, tests, and then it will notice that you're using testthat, and it will, call the appropriate tested functions, to do that. And it turns out that we have a typo somewhere here. Line 16. Oh yeah, this one is closed twice, right? This is not needed. Oh no, what's going on? Oh yeah, I know what is going on. What is going on is that, praise doesn't actually return the character vector or scalar, right? But it prints it to the screen, right? Which is a different thing. So what can we do about that? We can do two things. One is that we make praise return it as well, which is sensible, right? If you want to just to get it, without printing it, then in addition to printing it, then we can just return it, and then if we do load all and rerun the tests. Okay, so this is a little bit better. Except two things. One of them is that these things are printed on the screen, which it would be better, not to print them on the screen. And then there is an error message in the end. But other than that, yeah, it looks good. Okay, so the error message was something transient, probably. Okay, this is a little bit surprising to me. I'm not sure how to fix this, to be honest. To have the... we can suppress the output or do something similar, but I would just not do that now. It will be fine, with this glitch, if that's okay. Okay, so that's pretty good. We have a package, that has, some code, some documentation, some tests, and when we run check, either on our hub or locally. Let me just run something. Then the check, oh yeah, I don't have a proper email address in the description file, right? Okay, so when the check runs, you know, either locally or remotely on our hub, the check also runs the test cases, which is always, not always, but often, it's basically the most useful part of the check, that your test cases are running. It would be actually nice if there was a feature that we could only run the tests, say, on our hub, not just not the whole, you know, check, because otherwise it takes just too long to run all of it. Okay, so this will hopefully, you know, start doing the actual check, and then you will see that it's running the tests as well. I still have this error, right, that I haven't fixed. Oh, I see. And you remember I deleted this argument, so this is not documented now. So that's another, you know, failure with the check. But as far as the tests go, those are okay. So it says, you know, running tested R. That means checking tests, running tested R. That means that it's running the test, all the test cases, and they all passed successfully. So that's it, really. I'm really sorry you didn't get to try, you know, the RHub submissions from the command line. I told you this already, but the two things to look at if you want to know more. One of them is the R packages book, which is available for free, and the other one is the ultimate manual, which is the writing R extensions. I would look at the R packages book first, because it's just shorter, and the writing R extensions is long and often very detailed and technical details. But it has everything you need. On the other hand, yes. So that's a very good question. So how common it is, you know, that you have your checks are okay on one platform and they fail on another platform. So I would say with platforms, you know, like operating systems, it's not common if you only have R code. It's basically almost never happens if you have R code only. It's a lot more common if you have C code and C++ code, you know, compiled code, because the compilers are usually different on the different platforms. And what compiles on one platform, it might not even compile on another platform, not just behave differently. It happens that the other compiler cannot compile it. So with the R code, I think it's more useful to have different R versions, you know, because just having the development version, a most recent development version on your machine is not always so easy, you know, to do that. It's some extra work, especially if you want to maintain multiple versions on your own machine. So it's more useful, if you only have R code, it's more useful to have, you know, and have the ability to check your package on a different R version, the latest development version, say. So it's more like that. Yeah. 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 Yes. Yes. You can pass environment variables. You can pass, you know, RCMD check arguments if you want. So yeah, you can pass all these things. Yeah, you can customize it a little bit. Yeah. Okay. If there are no more questions, then thank you. And have fun at useR.